Today, we begin the first lesson of the new unit. And today's lesson, the Cartesian plane. The goal is to develop an understanding of the Cartesian coordinate system, including x-axis, y-axis, quadrants, and coordinates. So by the end of this lesson, you will be able to identify the coordinate system, label it, learn about the quadrants, and how to identify points and plot points on a coordinate plane. But before I go into the lesson, I just want to make an introduction to this booklet that we are starting off today, which is Unit 3, Introduction to Graphing and Linear Functions. Now, a copy of this can be found on the blog. So if you need a copy, it's in PDF format. There are 6 lessons in this unit. And this unit is the beginning phase that leads you into grade 12 applied math. So it's critical for you to complete this unit, and also the last one on quadratic function, which we will be beginning in a few weeks from now. Now, the first lesson is the Cartesian plane, which we will complete today and tomorrow. So by tomorrow, we'll finish lesson 1. Lesson 2, we're looking at displaying data and describing trends. Lesson 3, using technology to display data and find a regression equation. Now, at this point, lesson 3, you'll be introduced to the graphing calculator. Now, you don't need to buy any of these. If you're in the classroom, you get one to use in the classroom. But if you're not in the classroom, you can download a copy, download this calculator on if you're an Android phone. But it's also available free until June on Texas Instrument website. So I'll explain how to get this calculator on your phone or on your computer to use. You'll need it. And I'll give you step-by-step instruction on how to use it. So it's critical for you to follow through this booklet because it will help you to understand the graphing calculator, how to use it, because most of grade 12 will be using this calculator or some graphing technology, if not this one. But as of now, we'll be using this specific calculator here. Then lesson 4, we continue identifying characteristics of linear functions from a given equation. Lesson 5, you look at finding the intercepts of a linear function. And lesson 6, application of linear function. Linear means straight line function. So we'll be looking at essentially graphing on a straight line function in this unit. Now, if you go to the next page in your booklet, you'll find a checklist, and the checklist of the linear functions outcome overview. So by the end of this unit, you should be able to demonstrate all of these outcomes. So now, what you may want to do on your own is to go through each one of these outcomes and check if you can demonstrate an understanding of any one. If you can, that's fantastic, because it means you're a little bit ahead. If not, then you're in the right place because I'll be going through every one of these outcomes. So that's on page 2 of the booklet. So let's start the first lesson. The first lesson, in your booklet, it will have a different look to it. This is what it will look like in your booklet, but I'll just want to bring an introduction to you, for you. So let's look at our goal here. Develop an understanding of the Cartesian coordinate system, including x-axis, y-axis, quadrants, and coordinates. Now, the Cartesian plane, what it looks like, giving an overview, is sometimes referred to as the xy plane or the coordinate plane. And basically, it's used to plot data pairs or pairs of points on the two-line graph. So here we have two lines, x-axis, the horizontal line, and the vertical line, the y-axis. Now, this plane was developed by a French mathematician by the name of René Descartes. Now, René Descartes named it the Cartesian method because he was one of the founders of a philosophy or a scientific method called the Cartesian method. So that's why it was named the Descartes method. It was named the Cartesian method after the philosophical thought that he and other philosophers helped develop in the 17th century. And this came about because there was an emphasis before that of revelation, meaning that there was no rigorous scientific method. So knowledge was acquired through revelation rather than through scientific methods, through observation and testing. So he was one of the first thinkers to emphasize the use of reason to develop the natural sciences. The opposite of reason is we can have a priori, or be looking at revelation, meaning that someone from somewhere gave you this knowledge. Science, according to Descartes, should take a different approach where you test things before you come to a conclusion. For him, the philosophy of Cartesian, called the Cartesian method, basically embodied all knowledge. So René Descartes is given credit for the Cartesian philosophy system and also developed the Cartesian method, because prior to that, if you go back to our plane, we were wondering how can you put together reality on a two-dimensional paper. And so this was the beginning of modeling reality. So essentially, it became a model of organizing what we observe. So that's the Cartesian plane, a short history of it. And if you want to find out more, you can go online and look up the Cartesian plane method of René Descartes. Now, points on the Cartesian plane are called ordered pairs. So let's go back to your booklet. So if we have, this would be a Cartesian plane here. We have the x, and where they intersect is called the origin. So it'll be 0 here. Going to the right, they're all on the x-axis labeled positive integers, and to the left, negative integers. From the origin, it's called the origin here. Going up, we have positive integers on the y-axis, it's labeled y-axis. And going down, we have negative integers. So always going to the right is positive and up is positive, right of the origin here, where it intersect. So points on the graph or the Cartesian plane are called ordered pairs. And they're extremely important when illustrating solutions to equations in more than one with more than one data points. Well, that was simply put, the Cartesian plane is really two number lines, where we have two number lines here. Basically two number lines where one is vertical, called the y-axis here, and the other horizontal, called the x-axis. And they are at right angle, as we know here, right angle to each other, or they're perpendicular. So that's probably the simplest way to describe the Cartesian plane. So the Cartesian plane is just, you have just two number lines. So one number line going this way, it's like if you have a number line called x-axis here, and we have another number line called the y-axis. Where they meet at perpendicular or right angle, we call it the origin. And that's labeled as 0. It's like your starting point. So your starting point is your origin. So we have the vertical, horizontal. We always try to put an arrow here, meaning this is going to continuously, and they're right angle to each other. So the horizontal line is referred to as the x-axis. The vertical line is known as the y-axis. And the x, when you label a point, for example, if I want to know exactly where I am here, I'll label it 4, 2, brackets. So because I go first on my x-axis, so I travel here, I'm here. So now this represents 4. And this is a y, represented by 2. So we always indicate the x coordinate first, then the y, and a bracket around. So the easiest way to remember is like in the English alphabet, x comes before y, so we always go xy, never the reverse. You'll learn later on that because we have these two lines perpendicular to each other, there are 4 sections, and they're called quadrants. Quadrant 1, quadrant 2, quadrant 3, quadrant 4. And we're going in counterclockwise. Okay. So that's a brief overview of a Cartesian plane. In your booklet, this is what your booklet would look like. So to locate position of a particular point in the plane, the coordinate system is used. So this is your y-axis, that's your x-axis. And points are located by given coordinates that give the value of x coordinate and the y coordinate. So in the diagram below, point A, this is point A, oops, go down here. If you look at this diagram, you point 3, -2, so we go along. This is the origin, we call that 0 there. So this would be 0. And we always count from the origin going up. So 1, 2, 3, 4. So you want to find the coordinate 3, 2. You go along your x-axis first. And we find 3, and we will little indication decimal or line 3 on the x-axis, and we go down to -2, which is here. Where they intersect, that will be our coordinates. So you have an x coordinate and y coordinate. So x and y coordinate. And the x is always written first with a comma between, and then the y. So that's why they're called ordered pairs. They're called ordered pairs because they're written in a specific order, x and y, never y and x. Don't reverse them. As I mentioned earlier, the alphabet should give you a good indication of the order. X comes before y, therefore we'll indicate the x coordinate, in this case 3, comma, y coordinate. This is the origin where the x and y coordinates, x and y axis meet. So here we have a y-axis, and here we have x-axis. Where they meet is referred to as the origin. And it's always labeled 0, 0 here. So the origin will be 0 because x is 0 and y is 0 at that point. As I mentioned earlier, we have the 4 sections in our coordinate plane. And notice they're named after Roman numerals, 1, 2, 3, 4. And they're labeled counterclockwise. Now clockwise, because you're going to your left, starting from quadrant 1. Starting from quadrant as you go to your left. Right, so let's look at this here, give you a good. So here you have quadrant 1, and the x and y are positives in here. Then you move to the left, you're going counterclockwise. Quadrant 2, then you go quadrant 3, and quadrant 4. Seems that quadrant 1, 2, 3, 4. Now, if you want to plot, here I have this point here. I want to label that coordinate point. So I have 4 points here, 1, 2, 3, 4. Can you identify the ordered pair for the red, for the green, the blue, and for the purple? Think about it for a moment. Let's look at the A. Now you check your answers. This point here, let's label it A for now. This will be ordered. We go right along this line. It's on the vertical line. It go down. It hits the 4. So this will be x will be 4. Then I start from here going to the left. It hits the y at 2. So let's label it 4, 2. Positive 4, positive 2. Notice quadrant 1, positive and positive. So x is positive, y is positive. Quadrant 2 now, if you indicate here, the x is negative, the y is positive. Now let's see if that's true from our point here. We have a point here. We go straight down here to find our x coordinate. And yes, x is negative. So you have negative 5. And then I go horizontally, and it hits 5, so this will be 5. So this -5, +5. So this matches up with what is expected. Notice it goes straight down for my x and vertically down to find my x point, and then horizontally go get to find my xy coordinates. Third, according to our notes here, it should be negative and negative. X should be negative, y should be negative. Let's see how that works. We go straight up here, it hits -3. Put a comma, and horizontally, -3. So x is negative, y is negative. -3, -3 for our ordered pairs. This ordered pair is -3, -3. So we have these 3 ordered pairs. We have 1 more to go. So we go straight up. We have 2. Now it should be positive, which it is. And then go to my left, -6. So quadrant 1, or coordinate point, is 4, 2. Quadrant 2, our coordinate point, -5, +5. Quadrant 3, it's -3, -3. And quadrant 4 is 2, -6. Positive. It's understood if you don't indicate a sign in front of an integer, that is a positive integer. So that's locating points of ordered pairs on a Cartesian plane. In your booklet, here's some example. You have to plot the falling points on the coordinate system below or to the right. And then you're asked a couple of questions. So plot the following points on the coordinate plane. You have 2, 5. So there's going to be x, that'll be y. So this is my x-axis. And this is my y-axis. Y. So for the first ordered pair, x is 2. So go along, follow along my x-axis here. Find 2. So that's so somewhere along this line would be my ordered pair. I don't know which one. Now I need to look at my y. My y is 5, so I straight along here. Where they intersect, that's my ordered pair, 2, 5. So we can say that's A. B is -3, 1. So x is -3, y is 1. -3. So follow down. And y is 1. So there's my B. -3, 1. Next, -3, -5. So -3, -5. Make sure we got this all nicely where they intersect. So we see D is 7, -2. So we go along 7. And -1, -2 would be right there. So 7, -2 intersecting point. So it would be D 7, -2. Next we have 0, 3. So x is 0. So now this will be 0. Can leave that. That's the origin. Go up to 3. It would be here. So this would be 0, 3, E. Sorry. And lastly, -5, 0. So -5, 0 is right on the x-axis here. Oh, that's +5. Oh. -5, 0 will be right here. Yeah. So these are the points plotted on the coordinate system. The follow-up questions, which points above, or which point above located in quadrant 4? Now notice, we can label these as quadrant 1, 2, 3, 4. Just remember this is quadrant 1, quadrant 2, quadrant 3, and quadrant 4. So remember, you always go counterclockwise in your labeling. Now, which point above is located in quadrant 4? So we look at quadrant 4, this section here, D. So that will be D 7, -2. Which point is located on the x-axis? So this is your x-axis here. Let's remove any kind of a 0, -5, 0. Notice, whenever it's on the x-axis, the y-coordinate is 0. And whenever it's located on the y-axis, the x-coordinate is 0. So we have f, which is -5, 0. I will demonstrate a few of these, and would like you to complete them on your own. The rest that I haven't completed, same as for the next one. And tomorrow's lesson, or the next lesson, we'll be reviewing these questions. So let's look at the first one. Write the coordinates of each point on the grid below. So A, if you look at A, so now x-axis here. Now, what you could do, you could label this 1, 2, 3, 4. Make sure you're consistent in your labeling. This is 5, this would be 6, 7, 8, 9. So you have -1, -1, -2. And this will help you in identifying the points, the coordinate points. And just a reminder, whenever you're labeling the coordinate points, go back to our labeling. On the number line, the numbers or the integers are always below the x-axis. Don't put it above. And for the y-axis is to the left. That was here. The one right over here is 7. So it's a convention. So I'll complete A, C, every other one, and you'll complete the rest. And the next lesson, I'll review it. So look at A. So first of all, we go along the x-axis. A is 6. So the x point is 6. And the y doesn't go up. It's right on the x-axis. Therefore, it's 0. Let's look at C. It's right here. So we go down. It'll be 2, 3. So always say x first. So 2, 3. So I'll put 2, 3 there. So A is 6, 0. E is right on the x-axis here. So it will be -6, 0. H is on the x-axis. No, this is right on the x-axis here. So H would be 0, -4. And O, well, it's right on the origin, which is unique because x is 0 and y is 0. So I'd like you to complete the rest. Let's look at, now it's the reverse. You're given the following ordered pairs, and you're asked to plot these points on the grid below here. And I would go ahead and label it. It helps to clarify your labeling, plotting your points, I mean. So for now, I'll do A, C, E, G. And you will do the other ones. So look at the first one. A is 3, 5. So go along here, 3, like suddenly go straight up. So be somewhere along this line would be my point. Then look at Y is 5. So it intersects here. So this will be 3, 5. So point A. Notice both are positive because in quadrant 1. So we can label this quadrant 1. Let's look at C, -3, -2. So -3 is here. Go straight down. And -2. So -3, -2. That would be C. Here we have E, -2, 0. So -2, 0 would be right on the x-axis. G is 5, 0. So that's also on the x-axis. So your task is to complete B, D, F, and H. Want to try it for now while you can pause the video? Okay, now you give it a try. So now for B, it will be x is 0, y is 4. So this is B0 here, x is 0, y is 4, be right there. So B, right over here, 0, 4. So I'll highlight that. D, negative 1, 6, negative 1, up there is 6. Negative 1, 6. That would be D. F, 3, negative 6. So 3, negative 6 here, so it goes where they meet. And finally, H, 0, negative 3. X is 0, y is negative 3. Just let it go back to the first one. Hopefully you get a try. So once you can pause the video and complete writing the coordinates for each of the ones in highlighted. Okay, now you have the chance. Now B will be 6, 3. It's right here. So it'll be 6, 6, and this 3. D will be negative 2, 8. F, which is down here, would be negative 4, negative 2. So negative 2 along here, negative 4. And I would be, I shouldn't draw a line there, shouldn't be 3, 4. You may want to refer to your quadrants fact, GQ2, maybe this page here. So in which quadrant or on which axis do each of the following points lie? So notice if you have a negative, positive and a positive, it would be in here. Negative and a positive quadrant. So this would be quadrant 1. Quadrant 3 would be a negative and a negative. And quadrant 4 will be a positive and a negative. So here we have a positive and a negative. So it tells me right away that would be in quadrant 4. So if you were to look at this one here, we have 3. Or look at the one we did here, we have 3. And then we have 4, which will be negative 4. So 3, negative 5. So 1, 2, 3, negative 5 would be 1, 2, 3, 4, 5. 0, 1, 2, 3, 4, negative 5. 1, 2, 3, 4. So A, quadrant 4. B, those negative and negative, that will be in quadrant 3. C, positive and positive, in quadrant 1. And you can practice by creating a quadrant or using the one in your booklet. So here we have 5, 7, for example. We have 5 and 7 will be a little bit slightly above it. So it'd be in this quadrant here. Or you can create your own, get a much larger coordinate plane. So we have quadrant 1 for C. For D, be negative 2, 4. So you have a negative and a positive to be quadrant 2. And E, a negative and a negative would be quadrant 3. So we have F4, 6. So we have 2 positives, that'll be in quadrant 1. G, negative and a positive, that'll be in quadrant 2. So it'll be here. And if you're not too sure, just try plotting the points on the graph. For example, negative 8. Well, it's going to work here, but if you go back to your graph, here we have negative 8 going to the left, and our point is 5. So negative 8, 5 will be right here, which would be in quadrant 2. H, now this will be a tricky one because x is 0 and y is 4. So if you were to look, x is 0, y is 4. So we have x is 0, y is 4. So it's you can say it's in both quadrants, but in none of the quadrants, because it's on the y-axis. Okay. Because it's lying directly on the y-axis. So we can say it's applicable because it's on the y-axis. We can put here on y-axis. It's in neither of these two quadrants. It's ambiguous. It could be in quadrant 1 or quadrant 2. Therefore, we said it's not applicable. It's not in any of the quadrants specifically by itself. I is -5, -2. So -5, -2 will be in quadrant 3. So put I, quadrant 3. And finally, 3, -1. So here we have positive and negative, which should be in quadrant 4. And you can verify it by plotting the points. So we have positive 3. So we have 1, 2, 3. And then we have -1, which is down here. So that'll be in quadrant 4. This is for you to complete. For you plot the following on the grid provided. And the next lesson, I'll take this up. So today, our goal was to develop an understanding of the Cartesian coordinate system, including x-axis, y-axis, quadrants, and coordinates. And we discovered that the Cartesian plane referred to the x and y plane, and is used mainly to plot data pairs on a two-line graph. Here we have a two-line graph, plot points on it. That's what it's mainly used for. We learn about the x-axis, the y-axis. They are perpendicular to each other. And we label the x-axis where the x and y meet 0. And to the right of the y-axis, the x is labeled positive. To the left is negative. On the y-axis is labeled positive going up, negative going down. We learn about the 4 quadrants. 1, 2, 3, 4. And we discover that we can identify what quadrants they're in based on the signs of the ordered pairs. We plotted points in the ordered pairs, and we identify ordered pair points given, in this case here. And here we plot them. And your task is to complete question 4 on page 4.